see. Now that we have obtained the state space form, how do we obtain the transfer functions? That is the topic of the next explanation. So given the matrices A, B, C, and D, how do you obtain a transfer function or a set of transfer functions? Okay, so we have this example in here, and then from the example we have obtained this bond graph, and then we have obtained this state variables and the outputs, and we obtain the state space form like this. See, there is A, B, C, and D in here, and from this we produced the Simulink block diagram and did the simulation of the system. That's where it is. So what I am going to do is, let's put a nice title here. You would say, maybe you will say obtain the transfer functions using the A, B, and C and D matrices. Yeah? Okay. But let's just go back to the basics here. In here, isn't it true that I have my equations this way? I have A times X like this plus matrix B times the vector U, and then this is what I have, and this is C times X plus then D times U, like this. Yeah, okay. Now this in here is, I'm gonna go here, I'm gonna put set of differential equations. That's what they are, right? But what are the other ones? This is a set of output equations. If our objective is to obtain, as I say, the transfer functions using the matrices, then we need to start at the point here. But just as we did before, we should apply the Laplace transform to this and see what we get, because see, here's the transfer function is a relationship between the output vector and then the input, right? But we need to do something with these equations to be able to obtain this. So let's just make that definition as our objective. What are the transfer functions? Or transfer functions. This is the relationship between the output and then in relationship to the input, right? So what are the outputs in this case? This would be the vector y, and the input would be the vector u, right? This would define the transfer function. So what do we do to obtain that? Let me go back here, put it with black in here. Apply the Laplace transform to this equation. What would you get? You will get that S times X of S, like this, is equal to the matrix A times X of S, like that. Yeah. Plus then the matrix B times U of S, like this. Apply it to the output equations that we have over here also. You will obtain that this is Y of S equals to the matrix C times X of S, like this, plus the matrix D times U of S. Wonderful. So, in order to obtain this, we need to do something to only put these equations in terms of y and u. So what I would do is, using the first equation, I will write it like this. I will say Sx of s, like this, minus a times x of s, like this, equals to matrix B times U of S. Yeah? But you could continue here. You could write it as matrix. You could say S times the identity matrix minus A times X of S equals to B times U of S, like this. Yeah? And because we want this one to plug it into this equation, I would not save any steps, but I would just multiply both sides by the inverse of this. Yeah? And this is X of S. And then the inverse would be Si minus A, like this. And then multiply by B times U of S. Yeah? What is this? Huh?
One?
Yeah, it is. It is. It's one. No, he's right. And then you have here, then this is Si minus A inverse times U of S. Now, look, if you have this and you, how about we replace it over here? On the second equation, you will have that Y of S like this.
Dr. Grondin?
Yes.
You dropped your B.
Huh?
You dropped your B matrix. Where'd it go?
I did what?
The B matrix on the right side. Where'd it go?
Oh, yeah, yes.
You don't like that B matrix.
Right here, right?
Yeah.
It's here.
We need it in here. Okay. Now this is Y of S is equal to. Do you see where it says C, matrix C, and then this X? So we need to put all this. We need to do Si minus A, and then B, and then U of S. See, it's getting better now. This, and then plus D times U of S. See, now, take advantage of this and you say that this is equal to C times Si minus A times B times D multiplied by U of S, and then this is Y of S. Wow. Now look, we want this, right? And we are so close of getting that, because now you can write this, the Y of S relation to this.
Is it plus D, not times D?
Is what?
When you pull your U of S out, the line just above it, the line you just finished writing, C, Si minus A inverse times B plus D.
Yes, yes. C, and that is Si minus A, and then B, plus D. So it is possible that based on what I just did, that you will obtain a transfer function or a set of transfer functions for any system that has those four matrices and for any number of outputs. So if this is true, we can obtain the transfer function between any output and any input using the matrices. That was the point that I'm trying to tell you now. But you see, if you can go to the model itself and then produce the matrices, define the outputs, what I'm here to tell you is that CAMG does exactly what I just did. CAMG takes advantage of this, and that's how it obtained the transfer functions. And that's how we'll obtain the transfer functions that you have for your assignment as well. So let's go back for a moment over there, and then
what is the SI?
S is the Laplace operator. I is the identity matrix, because you need the identity matrix to do the summation of those two with the A matrix. So in here, if you go back and we go over here to the CAMG software and we put the example in here again. Yeah, and here you have this right there. There it is. Now if you go to the interface of MATLAB, you will see that it's going to give you a new set of matrices, and that we can relate to this ones. So I'm going to turn this ones off so we don't get it all confused. There it goes. In this file right here on the CAMGSYM file, we needed to define what did we have? E7 was one that we had, right? And that is, again, we do this because we are not on the Simulink side, we are on the MATLAB side. So we go here to 1. We're doing the same thing, but on the MATLAB side now. This is F2, I think it was. Yeah, and here we go. And now we are using symbols because we want those two transfer functions. And what I'm here to tell you is that CAMG, there it is. That's all you gotta do. If you look down here, if you look down here, right there, that statement that you see in there is exactly what's in this note. Do you see it in there? It says matrix C, the inverse of SI minus A times B plus D. And when you do that, watch this. Debug in here, you say the file and run. What you have it happen is, okay, where are we?
You're going to want to open your other map.
Sorry, here we go. There's the matrices. See the A, there is the B and the C. And now what will happen is, using that statement, look what it did.